Hello. So after the Laplace of the derivative function, we can also find the Laplace of the integral function. So Laplace of integral function. Okay. So for example, so we know that the function is in the form of an integral, and what will be its Laplace transform. So for example, we want to find the Laplace transform of a function which is given in the terms of integral. Okay, and that function will be in the form of uh, integral limits from 0 to t, and then the function will be in terms of the variable tau d tau. So then when it will be integrated with the limits applied, so the function will be in terms of t. So what will be its Laplace transform? So so in this case we say that this is the term in this integral. We can say that it is equal to gt. Okay, the term in this integral 0 to t f tau d tau is equal to a function in g. Okay, and not the original function itself. Original function is f of t. Okay, original function is actually f of t. Okay, and we are representing it in the integral form in this case. So when we apply some integration, and then we get the function in terms of t. So g of t is basically the integral form of this function. So by the definition of the integral, so for example, if we integrate left hand side, and then we get g of t. So in the opposite way, in the inverse way, if we will integrate g prime of t, then what we will get? So we will get the original function. Original function is f of t. So we can use this type of relationship. Okay, next we also know that if we take the Laplace transform of integral of a function, so for example in this case integral of a function is this g prime of t, so its Laplace transform will be equal to s times the Laplace transform of the function itself. Okay, the function itself. So if it is g prime t, then the function itself will be g of t, and then minus the value of this function evaluated at t is equal to 0. So now we have this equation, and this equation is from the derivation of the differential Laplace transform of the differential function. Okay, so in this case, what are these terms over here? Laplace transform of g prime of t is actually the it is the Laplace of f of t. Okay, so it is the Laplace of f of t, original this function. And then what is this s? S is s over here. And what is Laplace of gt? Laplace of gt is this original value which we want to find. Okay, so this is the original function. So Laplace of the integral 0 to t f of tau, this we wanted to find. So this is the unknown which we wanted to find. And what is g of 0? G of 0 is this function, this, and then we know that this g is an integral function, and if this integral function will be evaluated at 0, which means that from the limits of 0 to 0, okay, from the limits of 0 to 0, then that means from if we integrate from the limits of 0 to 0 or a to a or c to c, then that function is actually 0. So this term will be 0. So in this case, then what we can find out that what is the Laplace of 0 to t f of tau d tau. This Laplace we wanted to find. We can take s on that side, so it will be 1 over s. And what is the Laplace of f of t? Laplace of f of t we can represent as a function in terms of s. So this gives us the formula for the Laplace transform of an integral of a function. So if we want to find the Laplace transform for the integral of a function, so simply what we will do is we will take the Laplace transform of that function, which will be f of s, and then we will have to divide or multiply divide by s or multiply by 1 over s, whatever you want to say. So this is the basic formula for the Laplace transform of the integral of the function. In order to hold this formula for the Laplace transform for the integral of this function, the general conditions for the Laplace transforms, that means the Laplace transforms should be bounded under certain limited values. There will be some limited growth rule that will be applied. So under these conditions, this type of formula will hold. So now we will use this formula to solve some examples. Okay, so now let's apply this formula for one example. Okay, so remember that this type of formula is useful for finding the inverse transforms. For example, what does it mean by the inverse transform? So for example, if I say that Laplace of sine omega t is equal to Laplace of sine omega t is equal to what? Omega over s square plus omega square. Okay, so this is the Laplace. I can also say that inversely speaking, Laplace inverse of omega over s square plus omega square is equal to sine omega t. Okay, so if we have the function in terms of s, then I can by the inverse transform we can find the function in terms of t. Okay, so with this thing, so let's find the Laplace transform, Laplace inverse of 1 over s times s square plus omega square. So this is similar to this. Okay, 1 over s, and we have to find the inverse, but here we have 1 over s term over here. And similarly find the Laplace inverse of 1 over s square into s square plus omega square. So we have function in s, we have to find the function in t. So first let's do this one first. So this one we can write like this. So for example, we know that Laplace inverse of 1 over s square plus omega square, we can write like this: Laplace inverse 1 over omega, and then omega over s square plus omega square. Okay, so omega cancel, so it is same as this. But for this we know that 1 over omega is opposite, and for this we know that 1 over omega we can 1 over omega we can take out, and then Laplace, this will be Laplace inverse of omega over s square plus omega square. So 1 over omega, and then Laplace inverse of omega over s square plus omega square, this is equal to sine of omega t, as I have just told over here. So therefore Laplace inverse of 1 over s square plus omega square is equal to 1 over omega sine omega t. Okay, so now we know that Laplace inverse of 1 over s into 1 over s square plus omega square we want to find. So this we can write it like this: Laplace inverse 1 over s into 1 over s square plus omega square, and this has the resemblance of this integral formula. So for example, here we have this 1 over s square plus omega square, which is the f of s, and then here we have 1 over s. So this will be equal to the integral, okay, Laplace inverse of the integral. So it will be equal to the integral. So that means we can write it like this. It is equal to 1 over s integral of from 0 to t, that will be equal to 1 over omega sine omega t, okay, sine omega t. So in this case it will be in terms of the tau, and then d tau, okay. So this we can simplify 1 over s, and then sorry, because 1 over s is already there, so this will be simply the integral of this, okay. So integral of this will be the 1 over the Laplace of this will be equal to the 1 over s times the Laplace of the sine omega tau over omega, okay. So there will be no 1 over s, and this will be 1 over omega, and then we will integrate sine omega tau. So this will be the minus cosine omega tau divided by omega. Then the limits we will apply from t to 0. So this will be minus 1 over omega square. So cosine omega tau, and then tau will be replaced by t. So cosine omega t, and then cosine 0 is 1. So we will get because we will get like this. It is equal to 1 minus cosine omega t over omega square. So this will be the Laplace inverse of this, okay, 1 minus cosine omega t over omega square. Now similarly we can find the Laplace inverse of 1 over s square into s square plus omega square. So now we can write it like Laplace inverse of 1 over s into 1 over s into s square plus omega square. So we have just found the Laplace inverse of 1 over s square plus omega square. So now we can write it in the form of an integral 0 to t, and then it will be we can write it in the form of an integral, then it will be the same, this one, 1 minus cosine omega t over omega square. Sorry, now it will be t will be replaced by tau, okay, this we need to remember. T will be replaced by tau cosine omega tau, okay, and then d tau, okay. So take a little bit of space over here and then to expand it. So we can take 1 over omega square as outside, and then for 1 it will be tau. For cosine omega tau it will be sine omega tau over omega, and then from t to 0. So 1 over omega square, it will be equal to tau is t, and then minus 0, and then sine omega t, okay. So it will be minus sine omega t, and minus minus plus, and so sine 0 is 0, okay. So it will be omega and then plus 0. So now we will get t over omega square minus sine omega t over omega cube. So this will be the Laplace inverse of this function, okay, t over omega square over sine omega t over omega cube. Okay, so from the next video clip we will apply these concepts to solve the initial value problems. That means we will solve the differential equations in the next video clip.